So there are different types of nonlinearities and these nonlinearities can be classified differently. For example, we can classify the nonlinearities as inherent nonlinearities or intentional nonlinearities. What are inherent nonlinearities? These are the nonlinearities which are inherent to that physical process, and we cannot get rid of these nonlinearities. For example, centripetal force, that is always proportional to the square of the velocity, and we cannot get rid of that nonlinearity. And another example is Coulombic friction, that is also a nonlinear function of the position, this velocity, and again we cannot get rid of this. There are other nonlinearities which are intentionally added to control systems. For example, this on-off controller, we have already talked about it, so that is a nonlinearity and which is sometimes intentionally added to control systems. And adaptive control, that is another example of a nonlinearity which is intentionally added to control systems. So nonlinearities can be classified as either as inherent nonlinearities or intentional nonlinearities. Another classification of nonlinearities is nonlinearities can be continuous nonlinearities and these can be discontinuous nonlinearities. Examples of continuous nonlinearities is square of some term, square root, multiplication of variables. For example, in liquid level systems, you very commonly encounter this kind of square root nonlinearity. That is, this outflow rate is proportional to square root of the level of the liquid. And there can be discontinuous nonlinearities. For example, this dead zone which we have just talked about, and saturation nonlinearity, on-off nonlinearity. So we have already talked about this thing that these discontinuous nonlinearities are generally more problematic to handle because we cannot find their linear approximation, and these may have severe effect on the stability of the control system.